Picture this, a galaxy so chaotic and vibrant, it's nicknamed the CIGAR Galaxy, not for its shape, but for the explosive energy it radiates. Messier 82, as it's officially known, is a cosmic powerhouse, a starburst galaxy where stars are born and die at a rate that dwarfs our own Milky Way. But what makes this galaxy truly extraordinary isn't just its dazzling beauty, it's the sheer number of strange and mysterious phenomena that have left astronomers scratching their heads. From supernova explosions that light up the cosmos to galactic winds that stretch across unimaginable distances, the CIGAR Galaxy is a treasure trove of cosmic oddities. In this video, we're diving into 25 of the most bizarre and fascinating phenomena observed in this galaxy, each one more mind-blowing than the last. Why does this galaxy produce stars 10 times faster than our own? What's causing the mysterious X-ray emissions from its core? And how does its supermassive black hole defy expectations? Stick around, because by the end of this journey, you'll see the universe in a whole new light. Let's unravel the secrets of the CIGAR Galaxy together. Now, let's zoom in on the first of these cosmic marvels, the supernova explosions that light up the CIGAR Galaxy like fireworks in the night sky. Unlike our Milky Way, where supernovae are rare events, the CIGAR Galaxy experiences them at an astonishing rate. This is because it's a starburst galaxy, meaning it's in a frenzy of star formation. But with so many stars being born, there's also a dramatic increase in stellar deaths. Massive stars, those many times larger than our Sun, burn through their fuel quickly and end their lives in spectacular supernova explosions. These explosions are so powerful that they can outshine entire galaxies for a brief moment. But the impact of these supernovae goes far beyond their dazzling light shows. Each explosion sends shockwaves rippling through the galaxy, compressing nearby gas clouds and triggering even more star formation. It's a cosmic chain reaction where the death of one star gives birth to countless others. At the same time, these explosions blast heavy elements like iron and gold into space, enriching the interstellar medium and setting the stage for future generations of stars and planets. The sheer number of supernovae in the CIGAR Galaxy also shapes its structure. The constant barrage of explosions creates vast bubbles of hot gas, which push against the surrounding material and sculpt the galaxy's appearance. Over time, this relentless activity has turned the CIGAR Galaxy into a dynamic, ever-changing environment where the cycle of stellar birth and death plays out on a grand scale. So, while supernovae are destructive on an individual level, they're also a driving force behind the galaxy's evolution. They're a reminder that even in the chaos of the cosmos, destruction and creation are deeply intertwined. And as we'll see next, this interplay of forces doesn't stop with supernovae. It sets the stage for even more extraordinary phenomena. Now, let's turn our attention to another breathtaking feature of the CIGAR Galaxy, its intense star formation. This galaxy is a cosmic powerhouse, churning out new stars at a rate that's 10 times faster than our own Milky Way. Imagine a bustling factory, but instead of producing goods, it's creating stars at an astonishing pace. This frenetic activity is what makes the CIGAR Galaxy a starburst galaxy, a term that perfectly captures its explosive productivity. But what's driving this incredible star-forming frenzy? The answer lies in the galaxy's interactions with its neighbors. The CIGAR Galaxy doesn't exist in isolation. It's part of a cosmic dance with its close companion, Messier 81. The gravitational pull between these two galaxies has stirred up the gas and dust within the CIGAR Galaxy, compressing it into dense clouds. These clouds, in turn, become the nurseries where new stars are born. It's like shaking a snow globe where the swirling motion triggers a flurry of activity. This gravitational tug of war doesn't just create stars, it shapes the galaxy's entire structure. The intense star formation is concentrated in the galaxy's core, where the gas is densest. Here, massive stars are born in clusters, lighting up the galaxy with their brilliance. But this rapid star birth comes at a cost. The energy released by these young, hot stars heats up the surrounding gas, creating powerful winds that blow outward into space. These winds carry away material that could have formed even more stars, creating a delicate balance between creation and dispersal. The CIGAR Galaxy's star-forming activity is a testament to the dynamic nature of the universe. It shows how interactions between galaxies can spark incredible transformations, turning a quiet region of space into a vibrant stellar nursery. And as we'll see next, this intense activity doesn't just shape the galaxy, it also gives rise to some of the most dramatic phenomena in the cosmos. Now, let's shift our focus to one of the most dramatic consequences of the CIGAR Galaxy's intense star formation: its powerful galactic winds. These winds are not the gentle breezes we experience on Earth. They are colossal streams of gas and dust racing outward from the galaxy at incredible speeds. Picture a cosmic hurricane, but on a scale so vast it spans thousands of light years. These winds are driven by the combined energy of supernova explosions and the fierce radiation from young, massive stars, creating a force that reshapes the galaxy itself. As these stars burn brightly, they release enormous amounts of energy, heating the surrounding gas and pushing it outward. Supernova, the explosive deaths of massive stars, add even more power to these winds, ejecting material at speeds that can reach millions of miles per hour. Together, these forces create a relentless outflow that carries gas and dust far beyond the galaxy's boundaries, into the vast emptiness of intergalactic space. This process has profound implications for the CIGAR Galaxy's evolution. The winds strip away the raw materials needed to form new stars, effectively putting a limit on how much the galaxy can grow. Over time, this could lead to a slowdown in star formation, as the galaxy exhausts its supply of gas and dust. But it's not just about loss. These winds also play a crucial role in enriching the surrounding space with heavy elements forged in the hearts of stars. Elements like carbon, oxygen, and iron are scattered across the cosmos, seeding future generations of stars and planets. The galactic winds also sculpt the galaxy's structure, carving out vast cavities and shaping the distribution of gas and dust. They create a dynamic environment where new stars can form in the compressed regions left behind, while other areas are left barren. This interplay between creation and destruction is a hallmark of the CIGAR Galaxy's turbulent nature, showcasing the delicate balance that governs the life cycle of galaxies. As we continue our journey through the CIGAR Galaxy's mysteries, we'll see how these winds connect to even more extraordinary phenomena, revealing the intricate web of forces that shape the cosmos. Now, let's turn our attention to a phenomenon that has left astronomers both puzzled and fascinated: the mysterious X-ray emissions emanating from the core of the CIGAR Galaxy. Unlike the visible light we see from stars, X-rays are a form of high-energy radiation, and the intensity of these emissions from the CIGAR Galaxy is far greater than what scientists anticipated. This unexpected burst of energy has sparked a flurry of research as experts work to uncover the secrets hidden within the galaxy's heart. At the center of this mystery lies the galaxy's supermassive black hole. While black holes are often thought of as cosmic vacuums, they can also be incredibly active, especially when they consume large amounts of gas and dust. As material spirals into the black hole, it heats up to extreme temperatures, releasing torrents of X-rays in the process. This could explain some of the intense emissions observed in the CIGAR Galaxy. However, the story doesn't end there. Another possible source of these X-rays is the aftermath of supernova explosions. When a massive star reaches the end of its life and explodes, it doesn't just vanish, it leaves behind a supernova remnant, a shell of hot gas and debris that can glow brightly in X-rays. Given the CIGAR Galaxy's high rate of supernova, it's likely that these remnants contribute significantly to the X-ray emissions detected. But what makes the CIGAR galaxy's X-ray emissions truly intriguing is their sheer intensity. Even when accounting for the black hole and supernova remnants, the levels of X-ray radiation are higher than expected. This has led scientists to consider other possibilities, such as the presence of hidden neutron stars or the interaction of cosmic rays with the galaxy's magnetic fields. Each theory offers a piece of the puzzle, but the full picture remains elusive. These X-ray emissions are more than just a cosmic curiosity. They provide a window into the extreme conditions at the galaxy's core. By studying them, astronomers can learn more about the processes that drive the CIGAR galaxy's evolution and the role of high-energy phenomena in shaping the universe. As we move forward, we'll explore how these X-rays connect to other strange phenomena in the galaxy, revealing the intricate dance of forces that make the CIGAR galaxy such a captivating subject of study. Now, let's shift our focus to another fascinating aspect of the CIGAR galaxy: its unusually strong magnetic fields. These magnetic fields are not just a minor detail. They play a crucial role in shaping the galaxy's behavior and evolution. What makes them so remarkable is their strength, which is significantly amplified by the galaxy's intense star formation. As stars are born in the CIGAR galaxy at a rate far exceeding that of our Milky Way, the processes involved in their creation generate powerful magnetic fields. These fields are woven into the fabric of the galaxy, stretching across vast distances and influencing everything from the movement of gas to the behavior of cosmic rays. Imagine these magnetic fields as invisible threads, guiding and shaping the flow of material throughout the galaxy. One of the most striking effects of these magnetic fields is their ability to channel gas. In the CIGAR galaxy, vast clouds of gas are pulled and pushed by these forces, often funneling material toward regions where new stars are forming. This process not only fuels the galaxy's ongoing starburst activity, but also helps regulate the distribution of gas, ensuring that star formation continues at a rapid pace. But the influence of these magnetic fields doesn't stop there. They also play a critical role in the movement of cosmic rays, high-energy particles that zip through space at nearly the speed of light. In the CIGAR galaxy, the magnetic fields act like cosmic highways, directing these particles along specific paths. This can lead to the creation of intense radiation hotspots, where cosmic rays interact with gas and dust, producing bursts of energy that astronomers can detect from Earth. What's truly intriguing is how these magnetic fields interact with other phenomena in the galaxy. For instance, they can amplify the effects of supernova explosions, shaping the remnants left behind and influencing how energy is distributed throughout the galaxy. They also play a part in the galaxy's powerful winds, helping to propel gas and dust out into intergalactic space. By studying these magnetic fields, scientists gain valuable insights into the inner workings of the CIGAR galaxy. They reveal how the galaxy's extreme environment shapes its evolution, and how forces we can't see with our eyes play a pivotal role in the cosmic dance of creation and destruction. As we continue our journey through the CIGAR galaxy's mysteries, we'll see how these magnetic fields connect to other phenomena, painting a fuller picture of this extraordinary cosmic wonder. Now, let's turn our attention to another extraordinary feature of the CIGAR galaxy: the high-energy cosmic rays that permeate its vast expanse. These cosmic rays are not your everyday particles. They are some of the most energetic phenomena in the universe, traveling at nearly the speed of light and carrying immense amounts of energy. But where do they come from, and what role do they play in the galaxy's dynamic environment? The CIGAR galaxy is a powerhouse when it comes to producing cosmic rays, thanks to its intense star formation and frequent supernova explosions. When massive stars reach the end of their lives and explode as supernova, they release enormous amounts of energy, accelerating particles to incredible speeds. These particles, now transformed into cosmic rays, are ejected into the galaxy's interstellar medium, where they interact with gas, dust, and magnetic fields. One of the most fascinating aspects of cosmic rays in the CIGAR galaxy is how they interact with the galaxy's magnetic fields. As we've discussed earlier, these magnetic fields are exceptionally strong, acting like invisible highways that guide the movement of particles. Cosmic rays charged with energy follow these magnetic pathways, spiraling along the field lines as they travel. This interaction not only shapes their trajectories but also influences where they deposit their energy, creating hotspots of radiation that astronomers can observe. But the story doesn't end there. Cosmic rays also play a crucial role in heating the galaxy's interstellar medium. As they collide with gas and dust, they transfer energy, raising temperatures and affecting the conditions necessary for star formation. In some cases, this heating can suppress the birth of new stars, while in others, it can trigger the collapse of gas clouds, leading to the formation of stellar nurseries. It's a delicate balance, and the CIGAR galaxy's unique environment makes it a perfect laboratory for studying these processes. Another intriguing possibility is that cosmic rays could be linked to the galaxy's powerful outflows. As these high-energy particles interact with the interstellar medium, they may contribute to the forces driving gas and dust out of the galaxy, shaping its evolution over time. This connection between cosmic rays and galactic winds is still an area of active research, but it highlights just how interconnected the phenomena in the CIGAR galaxy truly are. By studying cosmic rays in the CIGAR galaxy, scientists gain valuable insights into the mechanisms that drive high-energy processes in the universe. These particles serve as cosmic messengers, revealing the inner workings of supernova, magnetic fields, and the interstellar medium. As we continue to explore the CIGAR galaxy's mysteries, we'll see how cosmic rays fit into the larger picture, helping us understand the forces that shape this extraordinary starburst galaxy. Now, shifting our gaze to another remarkable feature of the CIGAR galaxy, let's explore its dazzling infrared glow. This radiant phenomenon is not just a visual spectacle, it's a window into the galaxy's bustling star-forming regions and the intricate dance of dust and gas that fuels its cosmic activity. The CIGAR galaxy's infrared glow is a direct result of its intense star formation. As young, massive stars ignite, they emit powerful ultraviolet light which heats the surrounding clouds of dust. This heated dust then radiates energy in the form of infrared light, creating the galaxy's signature glow. What makes this glow so fascinating is that it reveals details invisible to the naked eye, allowing astronomers to peer through the veil of dust that often obscures star-forming regions in other galaxies. This infrared glow is more than just a cosmic light show. It's a treasure trove of information. By studying the patterns and intensity of this glow, scientists can map the distribution of dust throughout the galaxy. Dust plays a critical role in the star formation process, acting as the raw material from which new stars and planets are born. In the CIGAR galaxy, the infrared glow highlights dense pockets of dust where stellar nurseries are actively forming, giving us a glimpse into the birthplaces of future stars. Moreover, the infrared glow provides clues about the galaxy's overall structure and evolution. The distribution of dust is not uniform. It's shaped by the galaxy's powerful winds and magnetic fields, which we've discussed earlier. These forces sweep dust into intricate filaments and clouds, creating a dynamic environment where star formation is both fueled and regulated. By analyzing the infrared glow, astronomers can piece together how these forces interact, shaping the galaxy's past, present, and future. Interestingly, the CIGAR galaxy's infrared glow also helps us understand the life cycle of dust itself. As stars form and die, they recycle dust back into the interstellar medium, enriching it with heavy elements. This process, captured in the galaxy's infrared light, offers insights into how galaxies evolve chemically over time. building the ingredients necessary for planets and perhaps even life. The infrared glow of the CIGAR galaxy is a testament to the interconnectedness of cosmic phenomena. It's not just a byproduct of star formation, it's a vital piece of the puzzle, helping us understand how stars are born, how dust shapes galaxies, and how the universe continually reinvents itself. As we continue to unravel the mysteries of this starburst galaxy, the infrared glow remains a guiding light, illuminating the hidden corners of its cosmic story. Now, let's turn our attention to one of the most dramatic consequences of the CIGAR galaxy's starburst activity, its colossal outflows of gas and dust. These outflows are like cosmic winds sweeping through the galaxy at incredible speeds, reshaping its structure and influencing its future. The starburst-driven outflows in the CIGAR galaxy are powered by the energy released from its intense star formation. As massive stars are born and die in rapid succession, they unleash powerful supernova explosions and stellar winds. These forces act like cosmic bulldozers, pushing gas and dust outward into intergalactic space. The result is a breathtaking display of material being ejected from the galaxy, creating vast streams that stretch far beyond its visible boundaries. But these outflows are more than just a spectacular sight. They play a critical role in regulating the galaxy's star formation. As gas and dust are expelled, the raw materials needed to form new stars are gradually depleted. Over time, this process can slow down or even halt the birth of new stars, effectively putting a brake on the galaxy's starburst activity. It's a cosmic balancing act where the very forces that drive star formation also work to limit it. Interestingly, these outflows also have a profound impact on the galaxy's surroundings. The ejected material carries heavy elements forged in the hearts of stars, enriching the intergalactic medium with the building blocks of future stars and planets. This process, known as galactic recycling, ensures that the CIGAR galaxy's influence extends far beyond its borders, shaping the evolution of the cosmic environment around it. The outflows also provide a unique opportunity for astronomers to study the interplay between star formation and galactic evolution. By observing the speed, direction, and composition of these outflows, scientists can piece together how the galaxy's starburst activity has shaped its history. They can also predict how the galaxy might evolve in the future, as the outflows continue to deplete its gas reserves and alter its structure. In many ways, the starburst-driven outflows of the CIGAR galaxy are a testament to the dynamic and interconnected nature of the universe. They remind us that even the most violent cosmic processes are part of a larger cycle of creation and transformation. As we continue to study these outflows, we gain a deeper understanding of how galaxies like the CIGAR galaxy live, evolve, and ultimately shape the cosmos around them. Next, we'll delve into the supermassive black hole at the heart of the CIGAR galaxy, a mysterious force that adds another layer of intrigue to this already fascinating cosmic story. Now, let's shift our focus to the enigmatic heart of the CIGAR galaxy, a supermassive black hole that defies expectations. Despite the galaxy's relatively small size, this black hole is unusually active, making it a fascinating subject of study for astronomers. At the center of the CIGAR galaxy lies a supermassive black hole, a gravitational powerhouse that exerts a profound influence on its surroundings. Unlike many black holes in larger galaxies, this one is far from dormant. It's actively consuming matter, releasing immense amounts of energy in the process. This activity creates a dynamic environment around the black hole, where gas and dust are heated to extreme temperatures, emitting powerful radiation across the electromagnetic spectrum. The black hole's activity has a significant impact on the galaxy's evolution. As it devours material, it generates intense jets of particles and radiation that shoot out into space. These jets can travel vast distances, interacting with the galaxy's gas and dust. In some cases, they can even trigger new waves of star formation by compressing nearby gas clouds. However, they can also have the opposite effect, blowing away the raw materials needed for star birth and effectively quenching star formation in certain regions. What makes this black hole particularly intriguing is its unusual level of activity given the CIGAR galaxy's size. Typically, supermassive black holes in smaller galaxies are less active as they have less material to feed on. But the CIGAR galaxy's black hole seems to be an exception, possibly due to the galaxy's intense starburst activity. The rapid formation and death of stars may be funneling gas and dust toward the black hole, fueling its activity and making it a standout feature in the cosmic landscape. This black hole also plays a key role in shaping the galaxy's magnetic fields. As it interacts with the surrounding material, it can amplify and twist these fields, creating complex structures that influence the movement of gas and cosmic rays. These magnetic fields, in turn, affect how the galaxy evolves, adding another layer of complexity to the interplay between the black hole and its environment. Studying this supermassive black hole provides valuable insights into how such objects influence their host galaxies. It challenges our understanding of black hole behavior and highlights the intricate connections between galactic centers and their broader surroundings. As we continue to observe and analyze this cosmic powerhouse, we uncover more about the forces that drive the evolution of galaxies like the CIGAR galaxy. Next, we'll explore the rare and fleeting gamma-ray bursts detected in the CIGAR galaxy, another mysterious phenomenon that adds to the galaxy's cosmic allure. Now, let's turn our attention to one of the most elusive and explosive phenomena in the universe: gamma-ray bursts. In the CIGAR galaxy, these bursts are not only rare but also incredibly mysterious, offering a glimpse into some of the most energetic events in the cosmos. Gamma-ray bursts are brief but incredibly intense flashes of gamma rays, the most energetic form of light. They can last anywhere from a few milliseconds to several minutes, and in that short time, they release more energy than our Sun will emit in its entire lifetime. Detecting these bursts in the CIGAR galaxy has been a challenge, but when they do occur, they provide a wealth of information about the extreme processes happening within the galaxy. So, what causes these powerful bursts? One leading theory points to the collapse of massive stars. When a star many times more massive than our Sun reaches the end of its life, it can collapse under its own gravity, forming a black hole. This catastrophic event can trigger a gamma-ray burst as the star's outer layers are violently ejected into space. Another possible origin is the collision of two neutron stars, incredibly dense remnants of dead stars. When these objects spiral into each other, they can produce a spectacular burst of gamma rays. Studying gamma-ray bursts in the CIGAR galaxy is no easy task. Their fleeting nature means astronomers have only a brief window to observe them, and they often appear without warning. Additionally, the bursts are so intense that they can temporarily blind the instruments designed to detect them, making it difficult to gather detailed data. Despite these challenges, each detection provides valuable clues about the extreme environments and processes that produce them. One of the most intriguing aspects of these bursts is their ability to act as cosmic beacons. Because gamma rays travel vast distances across the universe, they can be used to probe the properties of the space they pass through. By analyzing the light from these bursts, astronomers can learn about the distribution of matter in the universe and even test fundamental theories of physics. The CIGAR galaxy's gamma-ray bursts also offer a unique opportunity to study the connection between these high-energy events and the galaxy's intense star formation. The rapid birth and death of stars in the galaxy may create the perfect conditions for gamma-ray bursts to occur, linking these explosive events to the broader story of the galaxy's evolution. As we continue to unravel the mysteries of gamma-ray bursts, each discovery brings us closer to understanding the extreme forces at work in the universe. These fleeting flashes of light remind us of the dynamic and ever-changing nature of the cosmos, where even the briefest events can leave a lasting impact. Next, we'll delve into the role of dark matter in the CIGAR galaxy, exploring how this invisible substance shapes the galaxy's structure and behavior in ways we are only beginning to comprehend. Now, let's shift our focus to one of the most enigmatic forces in the universe, dark matter. In the CIGAR galaxy, dark matter plays a crucial role in shaping its structure and behavior, offering a unique window into the invisible scaffolding that holds galaxies together. Dark matter is a mysterious substance that makes up about 85% of the matter in the universe, yet it doesn't emit, absorb, or reflect light, making it invisible to our telescopes. Despite its elusive nature, its presence is felt through its gravitational effects. In the CIGAR galaxy, dark matter's influence is particularly intriguing because of the galaxy's intense star formation and turbulent environment. One of the key differences in the CIGAR galaxy is how dark matter is distributed. Unlike in more quiescent galaxies, where dark matter tends to form a smooth, spherical halo around the visible structure, the CIGAR galaxy's dark matter appears to be more concentrated and unevenly spread. This irregular distribution is likely tied to the galaxy's interactions with its neighbor, Messier 81, which have stirred up the dark matter and altered its typical arrangement. The role of dark matter in the CIGAR galaxy goes beyond just providing gravitational glue. It also influences the galaxy's ability to form stars. The intense gravitational pull of dark matter helps funnel gas into dense regions where it can collapse and ignite new stars. However, the galaxy's starburst activity and powerful outflows also push back against this process, creating a dynamic balance between creation and destruction. Studying dark matter in the CIGAR galaxy has also provided clues about its fundamental nature. For instance, the way dark matter interacts with itself and with ordinary matter remains a mystery. Some theories suggest that dark matter particles might collide and scatter, while others propose that they pass through each other without any interaction. Observations of the CIGAR galaxy's dark matter distribution and behavior are helping scientists test these ideas and refine our understanding of this cosmic enigma. Another fascinating aspect is how dark matter affects the galaxy's rotation. In most galaxies, stars and gas on the outer edges rotate slower than those closer to the center. But in the CIGAR galaxy, the rotation curve, how speed changes with distance from the center, is influenced by the dark matter halo, which keeps the outer regions moving faster than expected. This phenomenon is a hallmark of dark matter's presence and provides further evidence of its role in shaping galactic dynamics. As we continue to explore the CIGAR galaxy, dark matter remains one of its most compelling mysteries. Its invisible hand shapes the galaxy's evolution, influences its star formation, and challenges our understanding of the cosmos. By studying this elusive substance, we not only learn more about the CIGAR galaxy, but also gain insights into the fundamental nature of the universe itself. Next, we'll examine the tidal interactions between the CIGAR galaxy and its neighbor, Messier 81, and how these gravitational dances have shaped both galaxies over billions of years. Now, let's turn our attention to the cosmic ballet unfolding between the CIGAR galaxy and its close companion, Messier 81. These two galaxies are locked in a gravitational embrace that has profoundly shaped their evolution over billions of years. This phenomenon, known as tidal interactions, is a key factor behind the CIGAR galaxy's intense starburst activity and its unique structure. Tidal interactions occur when the gravitational forces of two galaxies pull on each other, distorting their shapes and triggering dramatic changes. In the case of the CIGAR galaxy and Messier 81, their close proximity, just about 12 million light-years apart, has led to a series of gravitational tugs that have stirred up gas, dust, and stars within both galaxies. These interactions have not only warped their structures but also set the stage for the CIGAR galaxy's explosive star formation. One of the most striking effects of these tidal forces is the creation of long, sweeping tails of gas and stars that stretch out from both galaxies. These tidal tails are like cosmic fingerprints marking the history of their gravitational encounters. In the CIGAR galaxy, these interactions have compressed vast clouds of gas, triggering the birth of countless new stars. This is why the galaxy shines so brightly in infrared light, as its starburst regions are filled with young, hot stars heating up the surrounding dust. The gravitational dance between the CIGAR galaxy and Messier 81 has also influenced their rotation and internal dynamics. As the two galaxies pull on each other, they transfer energy and momentum, altering their orbits and reshaping their spiral arms. This ongoing interaction has left the CIGAR galaxy with a more chaotic and irregular structure compared to more isolated galaxies. Interestingly, these tidal interactions are not a one-time event but an ongoing process. Even now, the two galaxies continue to influence each other, with their gravitational forces still shaping their futures. Over time, this dance may lead to even more dramatic changes, potentially culminating in a full merger billions of years from now. By studying these tidal interactions, astronomers gain valuable insights into how galaxies evolve and interact over cosmic timescales. The CIGAR galaxy and Messier 81 serve as a living laboratory, offering a glimpse into the dynamic processes that shape the universe. Next, we'll explore the dense molecular clouds within the CIGAR galaxy, which serve as the birthplaces of its new stars and play a crucial role in its ongoing starburst activity. Now, let's dive into the heart of the CIGAR galaxy's star-forming regions, where dense molecular clouds act as the cosmic nurseries for new stars. These vast clouds of gas and dust are the raw materials from which stars are born, and in the CIGAR galaxy, they are unlike anything we see in more tranquil galaxies. Molecular clouds in the CIGAR galaxy are incredibly dense and turbulent, a direct result of the galaxy's intense starburst activity. Unlike the relatively calm clouds found in galaxies like our Milky Way, these clouds are constantly being stirred up by supernova explosions, galactic winds, and the gravitational interactions with Messier 81. This chaotic environment compresses the gas and dust, triggering the formation of new stars at an astonishing rate. One of the most striking differences is the sheer size and mass of these molecular clouds. In the CIGAR galaxy, they can span hundreds of light years and contain enough material to form thousands of stars. These clouds are also much hotter and more dynamic than those in quieter galaxies, as the energy from nearby supernova and young, massive stars heats the gas and drives powerful shockwaves through the clouds. Another key difference lies in the chemical composition of these clouds. The CIGAR galaxy's starburst activity has enriched its molecular clouds with heavy elements like carbon, oxygen, and nitrogen, which are forged in the hearts of stars and scattered into space by supernova. This chemical enrichment not only influences the types of stars that form, but also increases the likelihood of planet formation around those stars. The turbulent nature of these clouds also means that star formation occurs in bursts rather than steadily over time. In more quiescent galaxies, star formation is a slow and gradual process, but in the CIGAR galaxy, it happens in rapid, intense episodes. This bursty star formation creates massive star clusters that light up the galaxy and contribute to its overall brightness. By studying these molecular clouds, astronomers can piece together the story of how stars are born in such extreme environments. The CIGAR galaxy offers a unique opportunity to observe star formation on a grand scale, providing insights into the processes that shape galaxies throughout the universe. Next, we'll shift our focus to the galaxy's strong radio emissions, which reveal even more about its hidden features and the forces at work within it. Now, let's tune into the invisible symphony of the CIGAR galaxy, where radio waves reveal secrets that light alone cannot uncover. The galaxy's strong radio emissions are a direct result of its chaotic and energetic environment, offering astronomers a unique window into its hidden features. These radio emissions are primarily driven by two key factors: supernova activity and the galaxy's powerful magnetic fields. When massive stars explode as supernova, they release shock waves that accelerate particles to nearly the speed of light. These high-energy particles then interact with the galaxy's magnetic fields, producing intense radio waves that can be detected from Earth. What makes the CIGAR galaxy's radio emissions so fascinating is their sheer intensity. Unlike quieter galaxies where radio emissions are faint and sporadic, the CIGAR galaxy's emissions are continuous and incredibly strong. This is a direct consequence of its starburst nature, where supernovae occur frequently, and magnetic fields are amplified by the constant churn of star formation. Radio observations are particularly valuable because they allow astronomers to peer through the thick clouds of dust and gas that obscure much of the galaxy's visible light. While optical telescopes might see only the surface of the CIGAR galaxy, radio telescopes can penetrate deep into its core, revealing structures and processes that would otherwise remain hidden. For example, radio waves have unveiled vast networks of filaments and bubbles created by supernova explosions and galactic winds, painting a more complete picture of the galaxy's dynamic interior. Another intriguing aspect of these radio emissions is their ability to trace the movement of cosmic rays. These high-energy particles, accelerated by supernova shocks, spiral along the galaxy's magnetic field lines, emitting radio waves as they go. By studying these emissions, astronomers can map the distribution and strength of the galaxy's magnetic fields, shedding light on how they influence star formation and the overall evolution of the galaxy. The CIGAR galaxy's radio emissions also provide clues about the life cycle of stars. By observing how these emissions change over time, scientists can track the aftermath of supernova explosions and the birth of new stars. This continuous cycle of destruction and creation is a hallmark of starburst galaxies, and the CIGAR galaxy offers one of the clearest examples of this process in action. As we move forward, we'll explore another fascinating feature of the CIGAR galaxy: the intricate filaments of dust that weave through its structure, shaped by the very forces we've just discussed. These dusty filaments hold even more clues about the galaxy's turbulent past and its ongoing evolution. Now, let's shift our gaze to the delicate, thread-like structures that crisscross the CIGAR galaxy, its dusty filaments. These intricate formations are not just beautiful to behold, they are also a treasure trove of information about the galaxy's past and present. Shaped by the relentless forces of star formation and the powerful gusts of galactic winds, these filaments tell a story of chaos, creation, and transformation. The dusty filaments are primarily composed of tiny particles of dust and gas, which are swept up and sculpted by the galaxy's intense activity. As new stars are born in the galaxy's starburst regions, they release immense amounts of energy, heating the surrounding dust and gas. This process, combined with the shock waves from supernova explosions, creates turbulent flows that stretch and twist the material into long, wispy strands. What makes these filaments particularly fascinating is their ability to preserve a record of the galaxy's history. By studying their shapes, sizes, and distribution, astronomers can piece together the sequence of events that have shaped the CIGAR galaxy over millions of years. For instance, the filament's alignment often reveals the direction of galactic winds, which carry material out of the galaxy and into intergalactic space. This outflow of material plays a crucial role in regulating star formation, as it removes the raw ingredients needed to create new stars. Moreover, the dusty filaments act as cosmic signposts, pointing to regions where star formation is most active. In some areas, the filaments are dense and tightly packed, indicating the presence of massive molecular clouds where stars are born. In others, they appear more diffuse, suggesting that the material has been dispersed by supernova explosions or galactic winds. This variation provides a snapshot of the galaxy's ongoing evolution, showing how different processes interact to shape its structure. Another intriguing aspect of these filaments is their interaction with the galaxy's magnetic fields. As dust particles align with the magnetic field lines, they emit polarized light, which astronomers can detect to map the orientation of the fields. This information helps scientists understand how magnetic forces influence the movement of gas and dust, as well as the formation of stars and planetary systems. The dusty filaments also serve as a reminder of the interconnectedness of cosmic processes. From the birth of stars to the explosive deaths of supernova, every event leaves its mark on these delicate structures. By unraveling their secrets, astronomers gain a deeper understanding of the forces that drive the evolution of galaxies like the CIGAR Galaxy. As we continue our journey, we'll turn our attention to another remarkable feature of this galaxy: its massive star clusters, which shine brightly amidst the chaos of its starburst environment. These clusters are not only stunning to observe, but also hold vital clues about the galaxy's turbulent past and its future trajectory. Now, let's turn our attention to one of the most dazzling features of the CIGAR Galaxy: its massive star clusters. These clusters, glowing brilliantly against the backdrop of the galaxy's chaotic starburst environment, are not just a visual spectacle. They are also key to understanding the galaxy's dynamic history and future. The star clusters in the CIGAR Galaxy are among the brightest ever observed, outshining many of their counterparts in other galaxies. These clusters are formed in the heart of the galaxy's starburst regions, where intense gravitational forces and turbulent gas flows create the perfect conditions for star birth. Unlike the more gradual star formation seen in common galaxies, the CIGAR Galaxy's clusters are born in a frenzy, with hundreds or even thousands of stars forming simultaneously in a relatively small area. What makes these clusters particularly fascinating is their ability to survive and thrive in such a hostile environment. The galaxy's frequent supernova explosions and powerful galactic winds would typically disrupt or disperse star-forming material, making it difficult for clusters to hold together. Yet, in the CIGAR Galaxy, these clusters not only form but also grow to immense sizes and brightness. This resilience is a testament to the sheer density of material in the starburst regions, which allows the clusters to maintain their structure despite the surrounding chaos. As these clusters age, they undergo dramatic changes. The most massive stars within them burn through their fuel quickly, ending their lives in spectacular supernova explosions. These explosions inject energy and heavy elements into the surrounding gas, enriching the interstellar medium and influencing future star formation. Meanwhile, the less massive stars in the clusters continue to shine, gradually drifting apart over time due to gravitational interactions and the galaxy's overall motion. The study of these star clusters provides astronomers with valuable insights into the galaxy's evolution. By analyzing their brightness, composition, and distribution, scientists can piece together the timeline of the CIGAR Galaxy's starburst activity. For instance, clusters located closer to the galaxy's core tend to be younger and more densely packed, reflecting the ongoing star formation in these regions. In contrast, clusters farther out may be older and more dispersed, offering clues about earlier episodes of star formation. Another intriguing aspect of these clusters is their role in shaping the galaxy's overall structure. As they form and evolve, they contribute to the galaxy's gravitational field, influencing the movement of gas and dust. Over time, this interplay between star clusters and their surroundings helps to regulate the galaxy's star formation rate, creating a delicate balance between creation and destruction. As we move forward, we'll explore another fascinating phenomenon in the CIGAR Galaxy: the chemical enrichment of its interstellar medium, a process driven by the very stars and clusters we've just discussed. This enrichment not only shapes the galaxy's present but also lays the groundwork for its future evolution. Now, let's dive into a process that's as transformative as it is fascinating: the chemical enrichment of the CIGAR Galaxy's interstellar medium. This phenomenon is a direct result of the galaxy's relentless starburst activity, and it plays a crucial role in shaping not just the galaxy's present, but also its future. As massive stars within the CIGAR Galaxy's star clusters burn through their fuel, they don't just fade away quietly. Instead, they end their lives in dramatic supernova explosions, scattering their remains across the galaxy. These remnants are rich in heavy elements like carbon, oxygen, and iron that were forged in the hearts of these stars during their lifetimes. When these elements are ejected into the surrounding interstellar medium, they mix with the existing gas and dust, fundamentally altering its chemical composition. This process, known as chemical enrichment, is like cosmic recycling on a grand scale. The heavy elements produced by one generation of stars become the building blocks for the next. Over time, the interstellar medium becomes increasingly enriched with these elements, creating a more complex and diverse chemical environment. This enriched medium then fuels the formation of new stars and planets, but with a key difference. The new stars born from this material are more likely to have planets with rocky surfaces like Earth rather than just gas giants. The impact of chemical enrichment extends far beyond star formation. It also influences the types of stars that can form in the future. For example, stars born in an enriched environment tend to have different properties than those formed in a more pristine medium. They may burn hotter, live shorter lives, or even produce different types of planetary systems. This creates a feedback loop where each generation of stars leaves its mark on the galaxy, shaping the conditions for the next. Interestingly, the CIGAR galaxy's intense starburst activity means this process happens at an accelerated rate compared to more quiescent galaxies. The sheer number of supernova and the rapid pace of star formation ensure that the interstellar medium is constantly being replenished with heavy elements. This makes the CIGAR galaxy a kind of cosmic laboratory where astronomers can study the effects of chemical enrichment in real time. As we look ahead, this ongoing process of enrichment will continue to shape the galaxy's evolution. Over millions of years, the interstellar medium will become even more chemically complex, potentially leading to the formation of stars and planets unlike anything we've seen before. And as we explore further, we'll uncover how this chemical legacy ties into another remarkable phenomenon: the concept of cosmic recycling, where the galaxy's outflows and inflows create a delicate balance between creation and renewal. Now, let's turn our attention to a process that ties the galaxy's past, present, and future together in a remarkable cycle: cosmic recycling. This phenomenon is a testament to the interconnectedness of the universe, where nothing is truly lost, only transformed. In the CIGAR galaxy, the intense starburst activity we've discussed doesn't just create stars and planets. It also sets the stage for a continuous loop of creation and renewal. When massive stars explode as supernova, they don't just vanish into the void. Instead, they scatter their remains, gas, dust, and heavy elements across the galaxy. These materials don't stay adrift forever. Over time, they are drawn back into the galaxy's gravitational embrace, where they become the raw ingredients for new stars and planetary systems. This process of cosmic recycling is like a celestial conveyor belt. The material ejected by supernova and the powerful galactic winds we've explored earlier doesn't simply drift away. Instead, it's pulled back into the galaxy's dense molecular clouds, the very nurseries where stars are born. Here, the enriched gas and dust mix with the existing material, creating a richer, more complex environment for the next generation of stars and planets. What's truly fascinating is how this recycling process shapes the galaxy's evolution. Each cycle of star formation, death, and rebirth leaves its mark on the interstellar medium, gradually increasing its chemical complexity. This means that the stars and planets forming today are built from the remnants of stars that lived and died billions of years ago. In a very real sense, the CIGAR galaxy is a living, breathing entity, constantly renewing itself through this cosmic dance of creation and destruction. But cosmic recycling isn't just about the galaxy's internal processes. It also has implications for the broader universe. The material ejected by the CIGAR galaxy's outflows doesn't always stay within its boundaries. Some of it escapes into intergalactic space, where it can influence the evolution of neighboring galaxies and even contribute to the cosmic web, the vast network of gas and dark matter that connects galaxies across the universe. As we look to the future, this process of recycling will continue to shape the CIGAR galaxy's destiny. Over time, the galaxy's gas reserves will gradually deplete, slowing the pace of star formation. But even as the starburst activity wanes, the legacy of cosmic recycling will endure, ensuring that the galaxy's story is one of continuous transformation and renewal. This brings us to another intriguing aspect of the CIGAR galaxy's story: the role of polarized light, which offers a unique window into the galaxy's magnetic fields and the alignment of its dust grains. But more on that in just a moment. Now, let's shift our focus to a phenomenon that allows us to see the CIGAR galaxy in a whole new light, literally. Polarized light, a fascinating feature observed in this galaxy, offers astronomers a unique tool to uncover hidden details about its magnetic fields and the alignment of its dust grains. When light travels through space, it can become polarized, meaning its waves vibrate in a specific direction. In the CIGAR galaxy, this polarization occurs as light interacts with the galaxy's magnetic fields and the tiny dust grains scattered throughout its interstellar medium. These dust grains, often elongated in shape, tend to align themselves with the magnetic fields, acting like tiny compass needles. As light passes through these aligned grains, it becomes polarized, carrying with it information about the orientation of the magnetic fields and the structure of the dust. This phenomenon is incredibly valuable for astronomers. By studying the patterns of polarized light, they can map the galaxy's magnetic fields in remarkable detail. These fields play a crucial role in shaping the galaxy's evolution, influencing the movement of gas, the formation of stars, and even the behavior of cosmic rays. The polarized light also reveals how the dust grains are distributed and aligned, providing clues about the galaxy's history and the forces that have shaped it over billions of years. One of the most striking discoveries made using polarized light is the intricate web of magnetic fields that permeates the CIGAR galaxy. These fields are not uniform. Instead, they twist and turn, shaped by the galaxy's intense star formation and the powerful outflows we've discussed earlier. This chaotic magnetic environment is a testament to the dynamic nature of the CIGAR galaxy, where forces are constantly at work, reshaping its structure and driving its evolution. But the story doesn't end there. Polarized light also helps astronomers understand how the galaxy interacts with its surroundings. Some of the light we observe has traveled through intergalactic space, carrying with it information about the magnetic fields and dust beyond the galaxy's boundaries. This allows scientists to study not just the CIGAR galaxy itself, but also its influence on the larger cosmic environment. As we continue to explore the CIGAR galaxy, polarized light remains a powerful tool, offering insights that would otherwise remain hidden. It's a reminder that even the most subtle phenomena can reveal profound truths about the universe. And with that, we're ready to dive into another captivating aspect of this galaxy: the concept of starburst feedback, where the energy and material released by star formation regulate the galaxy's future evolution. But more on that next. Now, let's turn our attention to a phenomenon that acts as both a creator and a regulator within the CIGAR galaxy: starburst feedback. This process is a cosmic balancing act, where the very energy and material unleashed by star formation influence the galaxy's ability to create new stars in the future. It's a fascinating cycle that shapes the galaxy's evolution, and the CIGAR galaxy is a prime example of how this feedback mechanism operates on a grand scale. In the heart of the CIGAR galaxy, where star formation is occurring at an extraordinary rate, massive stars are born and live fast, explosive lives. These stars don't just shine brightly, they also release immense amounts of energy in the form of radiation, stellar winds, and eventually supernova explosions. This energy doesn't just vanish into the void, it interacts with the surrounding gas and dust, heating it up and pushing it outward. This process creates powerful outflows, which we've touched on earlier, but it also has another critical effect. It regulates the conditions needed for new stars to form. Here's how it works. When the energy from young, massive stars heats up the surrounding gas, it can prevent that gas from cooling and collapsing into new stars. In essence, the very act of star formation can stifle further star formation in the immediate vicinity. This is a key aspect of starburst feedback. It's a self-regulating mechanism that ensures the galaxy doesn't burn through its gas reserves too quickly. Without this feedback, the CIGAR galaxy might exhaust its fuel for star formation in a relatively short cosmic timespan, leaving it a quieter, less dynamic place. But starburst feedback isn't just about suppression. It also plays a role in redistributing material across the galaxy. The outflows driven by supernova and stellar winds carry gas and dust far from their origins, sometimes even beyond the galaxy's boundaries. This material can eventually cool and condense in other regions, seeding new pockets of star formation elsewhere. In this way, starburst feedback doesn't just limit star formation, it also spreads it out, creating a more balanced and sustainable cycle of stellar birth and death. In the CIGAR galaxy, this process is particularly intense due to its starburst nature. The galaxy's rapid star formation means that feedback effects are amplified, creating a dynamic and ever-changing environment. Astronomers have observed how these feedback mechanisms shape the galaxy's structure, carving out cavities in the interstellar medium and influencing the distribution of gas and dust. It's a vivid reminder that the universe is a place of constant change, where even the birth of stars can have far-reaching consequences. As we continue to explore the CIGAR galaxy, starburst feedback stands out as a critical process that ties together many of the phenomena we've discussed. It's a testament to the interconnectedness of cosmic events, where the actions of individual stars can shape the destiny of an entire galaxy. And with that, we're ready to delve into another intriguing aspect of this cosmic powerhouse: how the CIGAR galaxy acts as a natural particle accelerator, producing high-energy particles through supernova shocks and magnetic fields. But more on that next. Now, let's shift our focus to a phenomenon that turns the CIGAR galaxy into a cosmic laboratory: its role as a natural particle accelerator. This galaxy isn't just a hub of star formation and explosive activity. It's also a place where particles are hurled to incredible speeds, creating some of the most energetic environments in the universe. At the heart of this process are supernova explosions, which we've already seen play a major role in shaping the galaxy. When a massive star reaches the end of its life and explodes, it doesn't just release light and heat, it also generates powerful shock waves. These shock waves ripple through the surrounding gas and dust, accelerating particles like protons and electrons to nearly the speed of light. It's as if the galaxy has its own built-in particle accelerator, far more powerful than anything humans could ever build on Earth. But supernova aren't the only players in this cosmic acceleration. The CIGAR galaxy's intense magnetic fields also play a crucial role. These fields, amplified by the galaxy's rapid star formation, act like invisible highways, guiding and speeding up charged particles as they travel through space. Together, supernova shocks and magnetic fields create a dynamic environment where particles are constantly being energized, producing high-energy cosmic rays that can travel vast distances. What makes this phenomenon even more fascinating is its impact beyond the galaxy itself. The high-energy particles generated in the CIGAR galaxy don't stay confined within its boundaries. Instead, they escape into intergalactic space, contributing to the cosmic rays that permeate the universe. These particles carry with them clues about the processes that created them, offering astronomers a unique window into the inner workings of starburst galaxies like the CIGAR galaxy. Studying these cosmic particle accelerators isn't just about understanding the CIGAR galaxy. it's also about unraveling the mysteries of the universe's most energetic events. By observing how particles are accelerated and how they interact with their surroundings, scientists can gain insights into the fundamental forces that shape the cosmos. It's a reminder that even in the vastness of space, the smallest particles can tell us some of the biggest stories. As we continue our journey through the CIGAR galaxy, this phenomenon highlights yet another layer of its complexity. From star formation to galactic winds and now to particle acceleration, this galaxy is a treasure trove of cosmic wonders. And with that, we're ready to explore how the CIGAR galaxy's outflows are not just shaping its own destiny, but also influencing the wider universe around it. But more on that next. Now, let's turn our attention to a phenomenon that reveals how the CIGAR galaxy's influence extends far beyond its own borders: intergalactic pollution. This might sound like a strange concept, but in the cosmic sense, it's a process that plays a vital role in shaping the universe around us. The CIGAR galaxy's intense star formation and frequent supernova explosions don't just create chaos within the galaxy. They also send massive outflows of gas and dust hurtling into intergalactic space. These outflows are packed with heavy elements like carbon, oxygen, and iron, which are forged in the hearts of stars and scattered into the cosmos during supernova explosions. This material doesn't just vanish into the void. Instead, it becomes part of the intergalactic medium, the vast expanse of gas and dust that fills the spaces between galaxies. What's fascinating about this process is how it impacts the cosmic environment. The heavy elements ejected by the CIGAR galaxy don't stay isolated. Over time, they mix with the surrounding intergalactic medium, enriching it with the building blocks necessary for new stars, planets, and even life. This means that the CIGAR galaxy isn't just a starburst powerhouse, it's also a cosmic recycler, spreading the ingredients for future cosmic structures far and wide. But the story doesn't end there. These outflows also influence nearby galaxies. As the enriched material from the CIGAR galaxy interacts with other galaxies, it can trigger new waves of star formation or alter the chemical composition of their interstellar medium. In a way, the CIGAR galaxy is seeding its neighbors with the raw materials needed for their own evolution. This interconnectedness highlights how galaxies aren't isolated islands in space, but are instead part of a vast, dynamic network. Studying this intergalactic pollution provides astronomers with valuable insights into the life cycle of galaxies. By tracing the movement of heavy elements through space, scientists can better understand how galaxies grow, evolve, and interact over billions of years. It's a reminder that even the smallest particles ejected from a single galaxy can have a profound impact on the larger cosmic landscape. As we continue to unravel the mysteries of the CIGAR galaxy, this phenomenon underscores its role as not just a local marvel but a key player in the broader universe. And with that, we're ready to explore another intriguing aspect of this galaxy: the variable stars that flicker and change within its boundaries, but more on that next. Now, let's shift our gaze to a phenomenon that adds a flickering rhythm to the CIGAR galaxy's cosmic dance: variable stars. These stars are not constant in their brightness. Instead, they pulse, dim, and brighten over time, creating a dynamic light show that astronomers have been studying for decades. Variable stars are like cosmic lighthouses, their changing brightness offering clues about their internal processes and the vast distances they inhabit. In the CIGAR galaxy, these stars are particularly intriguing because of the galaxy's intense star-forming environment. The rapid birth and death of stars here create a unique backdrop for studying how variable stars behave and evolve. One of the most well-known types of variable stars is the Cepheid variable. These stars have a predictable relationship between their brightness and the time it takes for them to pulse. By measuring the period of their brightness changes, astronomers can calculate their intrinsic luminosity, or how bright they truly are. Comparing this to how bright they appear from Earth allows scientists to determine their distance with remarkable accuracy. This makes Cepheid variables invaluable tools for measuring not just the distance to the Cigar Galaxy, but also the scale of the universe itself. But Cepheids aren't the only variable stars in the Cigar Galaxy. There are also red giants whose brightness fluctuates as they expand and contract in the later stages of their lives. These stars provide insights into the final phases of stellar evolution, showing how stars like our Sun might one day end their lives. By studying these red giants, astronomers can piece together the life cycles of stars and understand how they contribute to the chemical enrichment of their galaxies. Another fascinating group is the eclipsing binary stars, where two stars orbit each other so closely that they periodically block each other's light from our perspective. These systems allow astronomers to measure the stars' masses, sizes, and even their temperatures with great precision. In the Cigar Galaxy, eclipsing binaries help scientists understand how stars form and interact in such a turbulent environment. Studying variable stars in the Cigar Galaxy doesn't just reveal details about individual stars, it also sheds light on the galaxy's structure and history. By mapping the locations and movements of these stars, astronomers can trace the galaxy's spiral arms, measure its rotation, and even estimate its age. This information helps paint a clearer picture of how the Cigar Galaxy has evolved over billions of years. What's truly remarkable is how these flickering stars connect the Cigar Galaxy to the broader universe. By using variable stars as cosmic yardsticks, astronomers can measure distances across vast stretches of space, helping us understand the scale and structure of the cosmos. They remind us that even the smallest changes in brightness can illuminate some of the universe's biggest mysteries. As we continue to explore the Cigar Galaxy, these variable stars serve as both beacons and storytellers, guiding us through the galaxy's past, present, and future. And with that, we're ready to dive into another cosmic puzzle, the possibility of past collisions that may have shaped the Cigar Galaxy into the starburst powerhouse we see today. But more on that next. Now, let's turn our attention to a phenomenon that might hold the key to understanding the Cigar Galaxy's explosive nature: cosmic collisions. The idea that galaxies can collide might sound like something out of science fiction, but in the vast expanse of the universe, such events are not only possible, they're common. And for the Cigar Galaxy, these collisions could explain why it's such a hotbed of star formation and cosmic activity. Galactic collisions are like cosmic car crashes, but on a scale so immense it's hard to fathom. When two galaxies come too close, their immense gravitational forces pull at each other, distorting their shapes and triggering bursts of star formation. For the Cigar Galaxy, evidence suggests that a past encounter with its neighbor, Messier 81, may have been the spark that ignited its starburst phase. This interaction would have sent shockwaves through the galaxy, compressing vast clouds of gas and dust and creating the perfect conditions for new stars to form. The gravitational tug-of-war between the two galaxies would have stretched and twisted their structures, leaving behind the chaotic, dynamic environment we see today. In fact, the Cigar Galaxy's irregular shape and intense star-forming regions are telltale signs of such a collision. But the story doesn't end there. Collisions don't just trigger star formation, they also redistribute material across the galaxy. As the two galaxies merged, streams of gas and dust would have been flung outward, creating the intricate filaments and outflows we observe. These structures are like cosmic fingerprints, preserving the history of the collision for billions of years. What's even more fascinating is how these collisions shape the future of galaxies. The Cigar Galaxy's starburst activity, fueled by its past encounters, will eventually deplete its gas reserves, leading to a quieter phase of evolution. But the legacy of these collisions lives on in the stars and structures they leave behind, offering a glimpse into the galaxy's turbulent past. As we piece together the evidence, it becomes clear that the Cigar Galaxy's story is one of cosmic drama and transformation. Its collisions have not only shaped its current form but also set the stage for its future. And with that, we're ready to explore the final chapter in our journey through the Cigar Galaxy's mysteries, its future evolution, and what it might look like billions of years from now. Now, as we peer into the cosmic crystal ball, let's imagine what lies ahead for the Cigar Galaxy. This galaxy, currently a fiery cauldron of star formation and galactic winds, won't always be the bustling hub of activity we see today. Like all things in the universe, it's destined to change, and its future holds a quieter, more subdued phase of evolution. The Cigar Galaxy's intense star formation is both its greatest strength and its eventual downfall. Right now, it's churning out stars at an astonishing rate, but this process comes at a cost. The gas and dust that fuel this stellar factory are finite resources. Over time, the galaxy's outflows, those powerful winds driven by supernova and young stars, will carry away more and more of this material into intergalactic space. Eventually, the galaxy will exhaust its gas reserves, and without this raw material, star formation will slow to a crawl. What happens then? The Cigar Galaxy will transition from a starburst galaxy to a more tranquil, aging system. The bright, young star clusters that currently dominate its landscape will fade, leaving behind older, cooler stars. The galaxy's once vivid infrared glow, caused by dust heated by newborn stars, will dim as the dust settles and the stellar nurseries go quiet. But this quieter phase doesn't mean the galaxy's story is over. In fact, it's just entering a new chapter. The stars that formed during its starburst era will continue to shine, some for billions of years. The heavy elements forged in their cores and scattered by supernova will enrich the galaxy's surroundings, seeding future generations of stars and planets. And the structures shaped by its turbulent past, its dusty filaments, star clusters, and magnetic fields, will remain as cosmic relics, telling the story of its explosive youth. In the grand timeline of the universe, the Cigar Galaxy's starburst phase is just a fleeting moment, but its impact will echo across cosmic history, influencing the evolution of nearby galaxies and the intergalactic medium. As we wrap up our exploration of this fascinating galaxy, we're left with a profound appreciation for the dynamic, ever-changing nature of the cosmos. The Cigar Galaxy reminds us that even in the vastness of space, nothing stays the same forever. And that's what makes the universe so endlessly captivating. And with that, we've reached the end of our journey through the 25 strange phenomena of the Cigar Galaxy. From supernova explosions to galactic winds, cosmic collisions to future evolution, this galaxy has shown us the incredible diversity and complexity of the universe. If you've enjoyed this cosmic adventure, don't forget to like, subscribe, and hit the notification bell for more deep dives into the mysteries of space. Until next time, keep looking up, there's always more to discover. As we bring our cosmic journey to a close, let's take a moment to reflect on the incredible phenomena we've uncovered in the Cigar Galaxy. From its explosive supernova and intense star formation to its powerful galactic winds and mysterious X-ray emissions, this galaxy has proven to be a treasure trove of cosmic wonders. Each phenomenon we've explored, whether it's the galaxy's magnetic fields, its high-energy cosmic rays, or its intricate dusty filaments, reveals a piece of the puzzle that makes the Cigar Galaxy so extraordinary. What makes this galaxy truly unique is its role as a cosmic laboratory. Its starburst activity, driven by interactions with neighboring galaxies, offers us a front-row seat to some of the most dramatic processes in the universe. The Cigar Galaxy doesn't just tell its own story, it helps us understand how galaxies evolve, how stars are born and die, and how the universe itself changes over time. But the Cigar Galaxy is more than just a scientific curiosity. It's a reminder of the vastness and complexity of the cosmos. Every strange phenomenon we've explored, From its gamma-ray bursts to its dark matter mysteries, challenges us to think bigger, to ask deeper questions, and to marvel at the beauty of the unknown. If this journey through the CIGAR galaxy has sparked your curiosity, don't stop here. The universe is full of mysteries waiting to be uncovered, and there's always more to explore. Share your thoughts in the comments below. What fascinated you the most about the CIGAR galaxy? And if you're hungry for more cosmic adventures, hit that subscribe button and ring the notification bell so you never miss a deep dive into the wonders of space. Thank you for joining me on this exploration of the CIGAR galaxy. Until next time, keep your eyes on the stars and your mind open to the endless possibilities of the universe. There's always more to discover, and the next cosmic mystery is just waiting to be revealed.